We would be starting the session now. Let me just share my screen. So let me quickly share what's the agenda of today's session is. Today is our first session on problem solving. So we would be looking at two problems. Okay, so can you just tell me are you comfortable with things like variables and functions?
Yeah.
So is it fine if we directly jump into the coding
Yeah,
part?
it's fine. It's fine. It's
Okay,
fine.
great. Okay, so our first question for today's session is we have to write a program to find the sum of first and natural numbers. Do you have any suggestions how we should start writing this program?
You can actually use for loops and you can.
Yeah, definitely. So we start with the brute force approach. Like, what's the first thing that comes into our mind? Suppose let's take an example. The number n that is given to us, let's say we need to find the sum of first and natural numbers, right? So like you already mentioned, we can start doing this by okay. Hi Mohammed, are you able to hear me? Hello Mohammed, are you able to hear me?
Hello, how are you doing today? I hope you're
Yeah,
doing
I'm
great.
great. Yeah, great. So you can see the screen, right?
Yes, I can see the screen.
Okay, so what we have discussed so far is since we need to find the sum of first and natural numbers, what Eol has suggested, we can start a for loop starting from number 1, because 1 is the first natural number. So we are taking an example of let's say n that is given to us is 10. And we need to find the sum of first 10 natural numbers. This is the brute force approach. What we can do is we can start a for loop, initialize it with a counter variable I equals to 0 until 10, because 10, like we have to count up to 10, and then we would increment the counter after every iteration. Okay. So like guys, whenever we are given any problem, you guys are expected to solve, and like if you are in an interview scenario, the interviewer expects you to solve an easy level problem in a time period of about 25 to 30 minutes. So even though that might seem a little smaller time, we actually 25 to 30 minutes are a lot. And generally, whenever you are given an algorithm problem, the first approach that we tend to take is we try to write this pseudocode for the problem. So like in this case, suppose we are not even familiar with this for loop. Let's just suppose that right now. We just know that we have to find the sum of first 10 natural numbers. So if we write that into the most mathematical form, what that tells us is we are basically what we are asked to do is just this: 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and we have to return this sum. Like this is the goal of our program, whatever we are going to write. So that's actually what we are doing in this for loop. We can start with a sum variable, and let's initialize it to 0, because initially our sum would be 0, and we are starting from I equals to 1. Sorry, it's not 0. Okay, so we have started our sum variable from 0, and in each iteration what we can do is we can assign the sum a new value, that is sum equals to sum plus I. So we are not doing anything else if I write it step by step. So what happens is when I is equals to 1 at the very first iteration, what would happen is sum would be incremented to 0 plus 1, because I is 1. So we get sum equals to 1. When we reach I equals to 2, sum would be because now the value of sum is 1, so in the second step sum would be 1 plus 2. Yeah, and so on, right? So I think this is pretty clear.
Yeah.
And once the loop finishes, we just have to either, like, it's your choice whether you can print the sum statement or you can return. If you are creating a function, you can return sum. So like, guys, this is still the brute force approach. Can you guys, like, can anyone tell me what's the time complexity if you go with this approach? What would be the time complexity? This is the linear approach, right? In terms of n.
I think it would be like O to N, like two parentheses.
Yeah, because we are simply just iterating it n times up to n. Okay, so we know that the time complexity in this
Yeah.
this is big O of n. Okay, how do you guys think that we should optimize this solution? Do you guys have any approach?
I think like we need to decrement increment the by 2 or by just by 5, like
Uh,
to
why would we do
optimize
that?
the solution. So
Uh,
so we need just because if we increment by 5, we will have like just 2 steps to reach 10. So this is why
uh,
I thought about it.
okay, but can you imagine what is the problem with this approach, with your approach? If we increment it by 5, uh, you're saying we would start from 0, we'd go up to 10 and you'd increment it by 5 each time.
Yes.
But did you notice that in, like, what we are supposed to do is we need to count every number, like we need to add every number into our final sum. So 1 would be there, 2 would be there, 3 needs to be there, 4 needs to be added, 5 needs to be added, and like each and every number we need to add. But in your approach, if you directly jump 5 increments, we would miss out on these numbers. Like, these numbers would never get added into our sum, so this would give us the wrong
Okay.
answer.
Okay, I see. So we need to not miss any number in the approach, right?
Yeah, we have to increment uh,
Okay.
by 1.
I thought my approach, I will just like we will reach the solution, we will reach just to 10. This is why I
Okay.
asked
Okay. See, your approach can work if the question, like, if we change the question, let's say we are changing the question. Right now, the question that is given to us is find the sum of first and natural numbers. But if this, if I change the question to find the sum of first and even natural numbers. Okay, if this is the question that is given to us, in this case, what we can do is we can start from I equals to 0, and we can increment it by 2 on each step. So I plus 2. Since we do not need to consider odd numbers into our solution, we can increment it by 2. So in first step I would be 0, in second step I would be 2, then if we increment it by 2 again I would be 4, in third step I would be 6, and so on. So yeah, your approach can work, but not in this question. If the question was to find first and even numbers, even then we have to like increment it by 2, not by 5.
Okay, I see.
Okay, so we have seen the brute force approach, which gives us the time complexity of O of n, right? Okay, so now if that is clear, let's try to come up with a more optimized approach. So we would try to make an observation here. Since we were told to add the first 10 natural numbers, and n in our case, let's say, for example, n equals to 10. Can you guys observe it that we are incrementing by 1 if we start from the left side? we are incrementing by 1 in each step, 1 plus 1, right? And similarly, if we go from right, we are decrementing by 1.
Yes.
Right. This is a pretty simple observation, right? We have just made these two observations, that if we start from left, we are incrementing by 1. If we start from right, we are decrementing by 1, right? So this is the observation, but when we make this observation, there is a hidden pattern. Like, let me write it like this. Can you guys see, if we start from left, like if we start from both ends, so 1 plus 10 gives us 11. Then again, we increment by 1 from left side and we decrement by 1 from the right side. So 2 plus 9, this again gives us 11. 3 plus 8 is again giving us 11. So like, we can see that it is a pattern that is repeating. And if we keep on doing that, like 4 plus 7 and 6 plus 5, this will also give us 11, and so on. So this, like, we have made an observation, and let me write it in this way. So this is this is basically what we're trying to do. We're starting from right and we are starting from left. So this is giving us 11, this is giving us 11, 11, and so on, right? So like, can we say, like, we are supposed to find the sum of first and natural numbers? Can we say the first and how many numbers are these? How many 11s do we have here? We have 10
10.
11s, right? Yeah, 10 11s. So
We have 10, 11. Yeah.
yeah, so can we say sum equals to 10 into 11? Would that be right to say? No, it won't be right, because what we are supposed to find is this S. This is what we are supposed to find, the sum of first and natural numbers. But here, if we are adding it, these two things, what we are getting is 2S. So actually the sum would be 10 into 11 divided by 2. This would give us the like the result that we want to get. Does this make sense, guys?
So
Uh,
my question is, okay. My question was like, how did you how we come to the conclusion that we need like to start from 1 and go to 2, and we find a particular number that is 11? Like, how we, just by observation, or we, or if you have like some steps, did you go through, like, to come to this conclusion?
okay. So let me share a couple of steps. These are the suggested steps that like good programmers tend to take. So first, like, whatever the problem that is given to you, try to read it twice, at least twice, because many times what would happen is, like, in our case, the problem statement was pretty simple. Like, it was just a one line of problem, so we could understand it just by reading it once. But as this process would progress, you would see that we would see many interview questions which are at least 10 to 15 lines longer. So I want you guys to make up practice from here on. Early, like, try to read the problem a couple of times and make sure that you understand the problem. Second step is actually writing the pseudocode. So are you guys aware like what a pseudocode is?
Yes,
Yeah,
pseudocode is the steps like we need to achieve the goal, like the program we need.
Yeah, like one, like what we are trying to do right now is we directly jumped into writing the code, but in pseudocode we try to mimic the code in simpler language. So like we did in this problem, we read the problem and uh, we wrote it on the paper like this, like 1 plus 2 plus 3 plus 4 plus 5 up to 10. So this actually makes you visualize what the problem is and what are the steps that we need to take. Right now this problem is pretty simple, so you guys might think that this is not very important, but in future problems I would make sure that we do it like this, and then you guys can see that it is actually a pretty productive way of solving problems. So when you write it like this, it is hard to pin out like the approach that we take, but it would only be visible to you when you try to write things like this. So we can see that if you start from right and if you start from left, we are getting a simple pattern. Like the third step in problem solving is try to recognize the pattern in the problem or in your pseudocode that you're written. So like it's not necessary that you would definitely find a pattern in every problem, but most of the times DSA problems require you to find a particular pattern. So if you uh, if you practice these three things, like I'm not giving you a guarantee, but most of the times you would be able to recognize a pattern. So that's basically what we did here. We started from left and we started from right, and we figured out that okay, we are getting a pattern. We whenever we increment by one and decrement by one and then add the two numbers, we are always getting the same number. So this is the pattern, and if you want to know more about this, the in programming we have a concept of prefix sum and suffix sum. Like these are two concepts that uh, many problems we can solve by using these two steps. I would share the link with you guys on these two things. Actually, these are the type of algorithms that are pretty famous in DSA problems, and we would be solving problems on this in the future. So don't worry right now if you are not able to if you're not able to come up with the approach by yourself. We are just trying to we're just trying to see we're just trying to learn to see a pattern in our problems, if that makes sense.
Ah, okay, I see now. I get the point.
Okay.
Prefix and suffix in this approach, right?
Yeah, prefix sum and suffix sum.
So is it like the suffix here is the S, the first S, and the second is the
uh,
prefix
no,
is the
don't
second
worry about
S?
prefix sum and suffix sum right now. I was just trying to tell you like
Okay.
these are the approaches that we would be taking in the future.
Okay, I see. I got.
Actually, this is in this problem we are not doing a lot. We are just creating a counter and then progressing from left and going from right. If you are not able to figure out the pattern, don't worry a lot about it. So what we did in the second approach is yeah. So here we can see that sum is equals to 10 into 11 by 2. And if we try to come up with a general formula for this problem, so here n was 10. Let's just replace n 10 with n in this problem. N into n plus 1 by 2. If we replace n into this formula, we can come up with a general solution. And now if we write the code for this particular problem using the second approach, like now we do not have to run a for loop because we have a formula, and we can directly put the value of n that is given us in the problem, and we can find the solution in just one step. So actually these are two steps. First we are multiplying these things and then we are dividing it by 2, but uh, in a broader sense, this is known as order of one time complexity. And order of one time complexity is the best time complexity that we can achieve in any case. So this is the best case scenario. So if we try to like compare approach 2 with approach 1, in approach 1 the time complexity was order of n, and in approach 2 the time complexity was of order of 1, right? So if n, let's say n is equals to 10 to the power 9, in first case it would take us about 10 to the power 9 seconds to find the solution, and in second case it would take us just 1 second to find the solution. So like you guys can compare that, right? Okay. Guys, just give me 1
Yes,
second. Like
it is the fastest.
yeah, just give me 1 second. My cat is bugging me. Let me just
Yeah.
okay.
Take care.
Okay, let's continue with the second problem of today's session. Like we need to we need to check whether a given number is prime or not. Okay, this is the goal of our program. We need to write a program to check whether a given number is prime or not. Are we guys familiar with what a prime number is?
Yeah.
Okay, so can you guys tell me what is the smallest prime number?
It has to be divisible by itself in one. I think.
Yeah, right. So the definition of a prime number is it should be divisible by itself, and 1. So guys, is 1 a smallest, is 1 a prime number?
Yeah, I think so. I think it has.
Guys, 1 is not a prime number. The smallest prime number is, like, the definition of a prime number is it should be divisible by
I
exactly 2
think
numbers.
I think
Yeah, please go on.
yes. I think like the first prime number is 2.
Yeah, the first prime number is, so the smallest prime number is 2, because the real definition of a prime number is a prime number is divisible by exactly 2 numbers. So that gives us like one number is 1. Any number that is divisible by 1, so let's say a number x, it should be divisible by 1 and it should be divisible by itself. If this number is divisible by anything else, this is not a prime number. Okay, so because 1 is only divisible by 1, that's why 1 is not a prime number. So the smallest prime number is 2, because it is divisible by 1 and 2 itself. So this is the smallest prime number.
Yes.
Okay, so like if we have to start writing a code for this problem, what should we do? Like, should we start a for loop? From where should we start the for loop?
We will start it from 2.
Okay, let's take an example. We need to find whether 24 is a prime number or not. So you're saying that we would start it from 2, and until where should we go?
24, I think. 24.
Okay. Let's not go until 24. Let's go till n by 1, right? Oh, sorry, n minus 1 right now. Because we are assuming, like, in the definition of prime number, that every prime number is divisible by 1 and itself. So here 24 is divisible by 1 and 24 if it is a prime number. So 24 we already know, 1 we already know. So we would go from 2 to 23, which is n minus 1 in this case. And like we can write a if statement here. If uh, if I is, if I mod, sorry, not I.
If I divisible by itself, like 1 and 24, it will be like.
Okay, so like, do you guys know what this percent operator signifies?
Yeah, the remainder. Right?
Yeah, remember. So this percent operator is like, this gives you the reminder. So what we're trying to do is we are trying to divide n by I, and we are checking if the remainder of after dividing n by I is equals to 0 or not. Because if the remainder of n by I gives you 0, that means n is divisible by I. So if that happens, yeah,
Can break out of that loop, yeah?
yeah, we can break or return false, whatever is suited. So let's say we are returning false. Is this code correct, guys? Do you guys think this code is correct?
Yes.
Okay. Actually, we are missing one thing here in this code, which is suppose the number is actually prime. So this condition would never run in that case. So let's just first take the example of 24. So
I think
uh, 24, if we start from I equals to 2,
Uh,
yeah, please go on.
I said yes because we need like to add an additional else statement. If we didn't add an a, like it wouldn't be this statement wouldn't run, so we will be having some problem knowing if it is prime or not.
So what you are suggesting is like we create an else statement here, right? Else, and what should we write in this else statement?
Is true, return true.
Uh, yeah. But what if I tell you this would give us the wrong answer?
can we set a boolean value?
I'm sorry. Can you?
So
And
okay.
can we set a boolean value at the start of the point?
Okay, okay. So
Then
before the for loop.
when yeah,
I think
Okay,
it will never reach here because uh, we are considering only n-1 conditions.
okay. Uh,
I think we can actually set a boolean value at the start and then check if the boolean value is not turned into false or true. It has to be prime.
yeah, that's an approach that we can take. So let's say we are. Let's assume I'm currently writing in JavaScript, so I would not be writing any data types. Let's say I write, I create a variable if true. Okay. I need to do something about this space, man. This is if let's create the variable and call it check, and initialize is to false. Mhm.
Devendra, why don't you write your code in an editor or something?
Yeah, that I was also thinking of doing this. So I think we would start that from the next session
Okay.
because this actually is very tough to write. Okay, so like what Eol has suggested is we can create a character like a variable of like a boolean variable, and uh, so I would come to this in a second. Let's first try to do it in this way. Like suppose we are creating a function and we want to return either true or false. So like the way that Mohammed told that we create an else statement and return true in that. But the problem in this way is suppose you start in the you start from 2. So let's take the example of 13. Not 13. Let's take the example of 15. Okay. Given number to us is n equals to 15. So if you start from 2, in the very first step, 15 is not divisible by 2, right? So this condition is not true because dividing 15 by 2 would not give us 0. And in your case, we would directly return true. And that would suggest that 15 is a prime number. But 15 is,
Yes, yeah.
yeah. So
So we
like
need
you
like to
can,
change just return true. Like we need like to in the first like if n of modulus of I equals 0, and we need to return true, and the other else we would just add false,
so
return false.
what we can do is we do not like because we want to check every number until n minus 1. So we need this for loop to complete first before returning before giving the final answer that the given number is prime or not. So what we can do is, after this for loop finishes, we can return true here after this for loop. So if this for loop is completed and we still didn't return false, then we would come to this line and we would return true. So, but if there is an I in the problem that gives us n divided by I equals to 2, then the program would stop on this line only, and we would not go further down.
Devendra, I think if we reach here, let's
Yes.
say that if we divide n by I and it returns 0,
Yep.
then it will return false, right? But it
Yep.
is just going to break uh, this if statement only, but the code will still run, right?
No, I'm talking about a function. And what I'm trying to say is, this whole code is we are creating a function, and this whole code is written into a function. In that case, the return statement would directly break out of that function.
Okay, yeah.
Okay. Yeah. Uh, Now let's come to the point that you all have suggested, and which I like. I also prefer to do it in that way. So what you all told is, we can create a uh, boolean variable before the for loop. So let's say var, and we name that variable equals to check. Var check equals to, and we say it is true. Okay. We initialize this variable to true, and then now we run our for loop exactly as we did in the last step. So we start from I equals to 2, then we go to I less than equals to n minus 1, and I plus plus. We check the condition whether the given number n is divisible by I or not. So if n is divisible by I, in this case, instead of returning false directly, what we can do is we can change the value of this check variable. So let's say check is equals to false. And once the for loop is completed, now after the for loop is completed, we can again change the value of check equals to true. Oh, no. This would not work because for loop would finish eventually, and okay. And we can create a break here. Yeah,
We can
yeah,
actually say
I can break.
We have to make some break, yeah.
Yeah, okay. Now the code is fine. Okay. And after this code runs, we can like wherever we are trying to call it, we can check whether this check function is true or false. And based on that, we can tell whether the number is prime or not. So I think if this is clear to you guys, we can move on. Is this approach clear to everyone?
Yeah.
Uh, okay, so I am assuming that this is clear to everyone. So, but guys, this is still the brute force approach, and you guys can see that the time complexity in this case is again order of n. So we need to optimize our approach. Here, what we have done is, like, we started with 2 and we went until n minus 1. So can you guys see any can you guys make any observation? How can we optimize this solution? Any observations? how we can optimize this solution. Okay, so like, do you guys agree in this approach? We started from 2 and we went until n minus 1. Can
Yeah.
we reduce these steps somehow? Because if we reduce the total number of steps, eventually we would optimize our solution. Is there any way we can reduce these steps and still find our answer?
Should we increment by 4?
Why by 4?
I think we can do one thing. Incrementing by 4 is not a proper solution. Let's say if the number is 5 and you start with 2, then you just go to 6 directly. So 5 is a prime number and you will never reach here. So I think the better solution would be to check if it is even or odd. So if the number is even, then we can reduce the even numbers and then start with odd only. And for the odd numbers, we can check if it is divisible by 3 or maybe 5
Oh,
if it ends with like we can make the combinations
okay,
to check if
but
the
in case of 21, like say the n given to us is 21, would
yeah,
your approach still work in that case? If
yeah.
you are,
So if
yeah,
it's 21, then we know that it's an odd number, and if we divide it by 3, then uh, you will just break out of the loop right away.
okay. Are there any odd numbers that are not divisible by 3 and 5, and but they are still not prime numbers?
Yeah, I think there are multiple odd numbers. Like I
Yeah,
can
so
think of
okay,
29.
yeah, but 29 is a prime number, right?
Yeah,
Uh,
5, 29. Yeah,
I think
okay.
41 is a prime number, right? Or 41 is not a prime number, right?
No, it's a prime number.
41. Ah,
Yeah, I guess 6 multiplied by 7 is 42. Yeah, 41 is a prime number.
41 is a
40,
prime number.
47 is
Okay,
also prime
so
number.
let's say we follow your approach. We have to first check whether n is even or odd, right?
Yeah.
If n is even, I'm just writing the pseudo code here. Then we can continue. Oh, sorry, not continue. We can directly return false because we know that it is not a prime number. If n is even, we know that n is not a prime number because it
Yeah.
is divisible by 2. Right? But in that case, we have to start the loop from 3 because if n is even and let's say because 2 is the smallest prime number, so 2 would be even and it would still be a prime number.
Yeah, we can exclude that and we can start with 3 and then we can uh, jump it by 2. So the loop would be 3, 5, 7, 9, 11.
No, then we have to start with 4 because if we start with 3 and jump with 2, we would only get odd numbers, right?
Yeah, so we want to check the odd numbers only. Let's say if the number is even and it's not 2, then there is no need to check if it is a prime or not.
Okay. Let's say n is odd.
Yeah, so we can start with 3.
Yeah. Uh, like okay, if n is odd, let's start with 3. I equals to 3. Uh, until where do you want me to run this loop?
Again, n minus 1.
N minus 1, right? Okay. And incremented by 1, right?
Plus 2, I
Plus 2.
think
Okay. Yeah,
3,
right.
5, 7. And also we can add one more condition here. We can check if the number is a multiple of itself. so we can reduce that possibility as well. Like for example, let's say if we take number 49, so if we hit 7, then we are going to know that it's definitely not a prime number since it is divisible by 7.
Okay, so if it's divisible by 7, so in that case we have to, like, where would you check whether it is how would you check whether it is divisible by 7 or not? Where would you put that condition?
I think yeah, you're right. This thing is redundant since we are checking for the odd numbers only. So 3, 5, 7, I think would be the better approach. I
Uh,
can't think of anything else right now.
Also, I think this approach, uh, let me just shift it above a little bit. Hmm. Even if we, let's say, even if we uh, take all the even numbers out of our problem, in that case, still, wouldn't you say that the order of complexity would still be order of n, if we suppose that n is a very high number?
But let's say um, the first thing is that we have to check if the number is divisible by a smaller number. So we're not going to start from let's say the value is 41209, then we are not going to start from
No,
4120.
let's just assume that you are only taking integers for the sake of simplicity.
Yes, yes. So I'm talking about a larger number like
Okay.
41,209.
Okay.
So we are not going to start in reverse order. We are going to start from 3 only. So if
Okay.
the number is divisible by 3, then the code would break right away.
Okay.
And then we can check, like we can reduce the number, like the number of steps in half with this approach.
Uh, let's say there is, like, do you know what is the biggest prime number? I, if I can recall it correctly, it's a very big number. It's of order something like 10 to the power 9. So suppose that is the number that is given to you, okay, of that order, of this high order. This is the
Mhm.
prime number that is given to you. In that case, your code would never break until you reach this number. Do you agree?
Yeah, yeah, right.
Yeah. So you can see that even with this approach, the time complexity is still of order of n.
Yes.
Yeah. So uh, you are right that we have reduced all the even numbers, but still the time complexity is still of order n in this case. So talking in an amortized way, we have not optimized it to a better time complexity. Uh, any other observation if you want to give?
Right now, this is the only thing I can think of.
Okay. Do you guys agree that any number which is like there would not be any number that is divisible, uh, let's say n by 2, let's assume. Let's say we are given a number n, and uh, there would not be any number greater than n by 2 that would divide the number n. Do you guys agree with this? Assuming that n is an integer.
Yeah, but there is one more thing. Let's say if um if we take a square root of that number,
Okay, square root of this number. Okay.
and then we run the loop to like uh, let's say the number is 100.
Mhm.
So we have to check if the number is prime or not. So in that case, we would take the square root, because square root is basically like it will give us the right value. Like
But how did you come to this conclusion that, like, how did you observe that we should only run up to square root of n?
yeah, so if it is 100, then I think we would know in only 10 steps that
Yeah,
it is
but
divisible.
how did you, like, what is the concept behind this? How did you reach to this approach? Because you are going
Um,
to the right direction. I just want to know, like, what is the thought, like the thought process behind this approach?
yeah, so I'm thinking that if there is any number n
Mhm.
that we have to check if it is prime or not. So in to check that, uh, like the number is divisible by 1 and itself only.
Yeah.
So I think 10 multiplied by 10 would give us 100. So in that case, we have to check if it is divisible by 10 only.
Uh, I still didn't get, like, how did you reach to that conclusion?
I can't explain like
Okay,
how it's going to
no,
work.
no worries. Actually, that is the correct answer, and we would reach to that. But let's start to build an intuition how we can reach to that point. How can we reach to, like, how can we observe that pattern, right? So, like, do you guys agree that there would not be any number greater than n by 2 which would divide n ever?
Yeah, right.
Yeah, right. Okay. Uh, so what we can do is we can run our for loop from I equals to 2 to I less than equals to n by 2 and I plus plus, and repeat the same code here, right? Which we did previously. So, like, doing it in this way, we have reduced half of the problem set. Earlier, we were going from I equals to 2 to n minus 1. Now we have reduced it to half.
Yeah.
Yeah. But still, if you see that, if let's say n is of order 10 to the power 9, we know that n by 2 would again be of order 10 to the power 9. So still the time complexity remains of order n. Uh,
Yes.
does this make
Right.
sense? Yeah.
Yeah. 10 to the power 8, I think.
Mm. So, like, if this makes sense, let's try to do one thing. Where is my cursor? Okay. Let's say we are given a number n, and we need to find out whether it's a prime number or not, right? Uh, let's take the example uh, n equals to 24. This is the number that is given to us, and we need to find out whether 24 is a prime number or not. Again, following the steps that we have discussed earlier, how do we go on about solving a problem? We first try to write it in mathematical form. So uh, let's try to find the factors of 24. So we know that 1 is a factor of 24, right? For sure. 2
Yeah.
is a factor of 24, right? 3 is a factor of 24. 3 into 8, right? 3 into 8 would give us 24. Then 4 into 6 would give us 24. So 4 is again a factor of 24. 6 is a factor of 24. 8 is a factor of 24. Uh, and do you have any
12.
other number? Yeah,
12.
12. Yeah, and finally 24. So we can see that these are all the factors that all the factors of 24, right? So now if we try to find a pattern here, let me try to write it in this way: 1 into 24, 2 into 12, 3 into 8, then 4 into 6. Do you guys see any pattern, like how we can reduce our problem set here?
Okay, yeah, I get it now. So if uh, let's say the number is 41, for example, then the there would be only one set here, 1 multiplied by 41.
40, okay, yeah, but that's in the case when it is a prime number. When it is not a prime number, we still have these many numbers, right?
Yes.
Okay, so the observation here is, guys, we can observe that once we get one factor, uh, once we get one factor, we automatically get another factor as well. So because 1 is 1 into 24, right? 2 into 12 would again give us 24, 3 into 8. So the observation we can make is that divisors or divisors of any number n always exist in pairs. Uh, does this make sense?
Yep.
Yes, it does make sense. Yeah.
Okay, so once we find one factor, we automatically find another factor as well. Okay, so let's try to build up on this observation. One, we are taken n as 24, and these were the factors. uh, can we divide this set of divisors into two equal halves? Let's just make an imaginary line and divide our set into two equal halves, right? And let's call that a number of a variable on left side are represented by a, and variables on right side are represented by b. So 1 is a, 2 is a, 3 a would be 3, a would be 4, and after this half line we are calling these numbers as b. So what we are trying to do is we are trying to make an observation that if we can get until this half line, we do not need to go anywhere further, because if uh, if we find a divisor in this range, we can we know for sure if we do not find a divisor in this range, we know that there would not be any any divisor on the right hand side as well, because they always exist in pair. So if the left side is empty, uh, it is uh, it is it is compulsory that the right side would also be empty. Okay, so guys, can you tell me what is the maximum value that a can take given any number a randomly? Can I say that the maximum
Well,
value a can take is under root of n?
yes.
Okay, so this was the approach that Arpit was going to. So uh, from this observation, we can say that the maximum value a can take is under root of n. And if we do not find any divisor on until under root n, we do not need to go any further than this. So now if we try to run our loop, we would start again from I equals to 2, and we would go to n less than equal to under root n. So like guys, can you see that in each observation, like in each optimization, we are trying to reduce this, the end value of our loop. Earlier in the first approach, it was n minus 1, then it was n by 2. Now it has come to root n. So what we are at the end of the day trying to do is we are trying to minimize the number of steps to reach our goal. That would give us the most optimized solution. Okay, so again, the inner code would remain same. If and is divided by 2 gives us 0, we can return false. So nothing has changed in the entire code instead of this one value. And now the time complexity is of order of under root n. And just to give a perspective, let's say n given to us is 10 to the power 6. In first two cases, and let's just assume each operation takes us about 1 millisecond, right? So in this case, it would take us 10 to the power 6 milliseconds, which is about 10 to the power 3 seconds, which is about 16 minutes, right? But in this optimized approach, if n is 10 to the power 6, this would take us root n. So root of 10 to the power 6 would be 10 to the power 3. That gives us about 1 second. So guys, now tell me, like, would you like to go on a website that gives you an answer in 16 minutes, or would you like to go to a website that gives you an answer in just 1 second? Definitely the 1 second one, right?
Yeah.
Yeah, obviously.
Yeah, so like I remember someone in a couple of sessions before asked me, like, is it important that we do DSAs to become a good website developer? So this is the answer, guys. Because in most of the cases, we, like, it is a human psychology that we tend to think our answers into linear form. But you can see that if we try to find our answer in linear form, just trying to write a simple code to find a prime number, it would take us this much time. And like, there is no developer who makes these kind of websites in today's day and age, right? So definitely DSA, like, knowing the knowledge and like having a good knowledge of time complexities and algorithms and data structures, that is a must in whether you want to be a web developer or uh, any other domain that you want to go in. So, like, guys, if you still have any questions, you can ask me now. These were the two questions that I planned for you guys today.
I have one question.
Okay.
There was another approach that we were trying to see if the number is even or odd. So can we still implement that?
In this approach, in this final
Yeah.
approach.
Yeah.
Okay.
So in this approach, if the number is, let's say, an odd number, then we don't have to check for these other even numbers.
Okay, let me just try. Let's say you are given a number I, or given a number n, and uh, you want to check first, right, whether it's an odd number or even number, right?
Yeah.
Okay. Let's do that here. N divided by 2. If this case is true, we can break, right?
Yeah.
Okay. And else, if it's odd, now you are saying that we write our code in this, right?
Yes. Yeah.
Okay. Yeah, we can do that. Definitely, we can do that. But it would not make that much of a difference, like we saw in previous slides. The time complexity remained from order n to order n. So in this case,
Okay.
again, the time complexity would remain from order of root n to root n. So
Okay.
although this is a good observation, but this would not drastically change our solution.
Right. Okay.
Uh, any more questions?
I have just one. Yes, I have a question. My question is like in each situation or in each problem, we need like to have like the most optimized algorithm to like to do the steps. But how we do know like the best algorithm to do in each solution?
Okay. So like in like for most of the things that we are looking right now, like if you remember in the very first session, we took a problem of finding square root of n, right? Do you remember? In our very first session, we did
Yes.
this problem, right?
Yeah.
Today we are trying to find prime number, and before this, today we tried to find uh, the sum of first n numbers. So, like whichever programming language you choose, you do have inbuilt function to find these things. For most of the things, for most of the mathematical things, you do have inbuilt function. So in Java, I think it is sqrt. This is the function, right? If I'm right, Arpit, is this the function?
Yeah, in Java and JavaScript as well.
Okay. So
I think
uh,
also in C sharp, this is the same function.
And Python.
okay, great. Like the inbuilt functions, we can pre-assume that these are the most optimized ones. Uh, like scientists who build these languages, they already like behind the curtains, they are implementing the most optimized solution for us. So in day-to-day scenarios, you can like uh, if you can use these inbuilt functions with closed eyes without any shadow of doubt. But to like there are many cases. So say let's say there is no function to find, there is no inbuilt function to find the prime number of a number, right? To check whether a number is prime or not. So in those scenarios, we need to write the most we need to find the most optimized approach. So like what I'm trying to say is in most of the cases, you do not have to worry about these. If there is an inbuilt function, you can assume that it follows the most optimized approach. But if you cannot find an inbuilt function, which would be in most of the cases, in those cases, we have to find the most optimized approach. So like you talked about game
Okay.
development, right? So in game development, like we have to do a lot of calculations, right? We have to manipulate coordinates and all. So it is not
Yes.
necessary that you would find an inbuilt function for each of those tasks. So you have to figure those things out by yourself. Also,
Yes,
like
it's supposed like to write it.
yeah, please go on. What were you trying to say?
No, no, just go ahead.
Okay.
Just the connection is a little bad.
Okay. Also, guys, like I like we forgot to mention there are like in today's day and age, nobody has time to do all these calculations, right? If they need to find a solution, they you can directly Google these, like what is the most optimized approach to find a prime number, and you would find many reputed websites that would have a ready-made solution for you. So like Stack Overflow, if you guys have heard about it, you can pretty much find any algorithm on this website. Their Geeks for Geeks is another very good website. MDN, I think Arpit has already shared in the group. This is another very good website. So you can definitely find the most optimized solution for your problem whenever you get stuck into your day-to-day programming life. You can go to these websites and definitely you would find a pretty good solution for your problem. Like the purpose of doing these sessions is because in a case that you do not find a solution in these websites, then you have to figure it out on your own. And many times it happens to us like day to day, that we do not find answer to every problem, so we have to figure those things out by ourselves. So I think like today's session is almost over from my side. If you guys have any questions, you can ask now, like any questions relating to today's session. Okay, so I think we can finish this session. And Arpit, would you be taking the next session?
Yeah,
Okay,
I'll
great.
be doing this today.
Okay, okay, so thank you guys. The session is over from my side.
Yeah, thank
Thank
you
you.
so much. Have a great day.
Okay, have a great day. Thank you.
Thanks.
Thank you.
Yes.